Okay, this is the solution to question 2 of the assignment. So the setting is that the company has 30 seats in a flight and the company can sell more than 30 tickets if it wants to. And if some tickets are sold, then each customer independently turns up with probability 0.75. So if 31 tickets are sold, then there are two possibilities. No more than 30 people turn up or 31 people turn up. The probability that no more than 30 people turning up is computed by using the binomial distribution function, that's binomdist. And this function allows for 4 arguments. The first is the number of people turning up, that's 30, out of 31 purchasers, and each person turns up with probability 0.75, that's the third argument, 0.75. And in the last argument, you specify whether it is a cumulative probability or the exact probability. Here we choose true because we want the cumulative probability, that is the probability that exactly 30 or less than 30 people turning up. Such probability is 0.9998. The probability that exactly 31 people turning up can be also computed by the binomial dist function, and that's 31 out of 31 purchasers turning up, each with the probability 0.75. And this time we choose false because we want the exact probability, not cumulative probability. And such probability is very small, 0.00013. The cost of compensation, so basically if some customers cannot take the flight, there is overflow, the company has to pay £2,000 for each customer who couldn't take the flight. So the cost of compensation is 2 times the number of people turning up minus the number of seats in the plane, 30. Okay, so that means that if no more than 30 people turn up, then the cost is 0, but if 31 people turn up, then one person cannot take the flight, so the cost of compensation is £2,000. So here is the number of tickets sold, and let's compute the expected compensation cost, which is inner product of this probability vector and the corresponding cost. Yeah? Don't invent your formula. Always stick to the mathematical definition. The mathematical definition of the expectation of a random variable, or the mean of a random variable, is probability times the corresponding value plus the probability times the corresponding value, and so on. Okay? So the expected cost is £0.00026,000, and consequently expected net revenue is the expected sales minus expected cost. The sales is not uncertain. The sales is £31,000 because 31 tickets are sold. So the expected net revenue is the sales £31,000 minus the expected cost, and that is equal to £30.999 thousand. Okay, that's when 31 tickets are sold. So it's more profitable to sell 31 tickets than just selling 30 tickets. But what if the company sells 32 tickets? Can the company make even more profits? it is very likely. So let's do that. Now 32 tickets are sold, and correspondingly there are 3 possibilities. 30 people, 31 people, or 32 people turn up. Actually, let me type 30 F5 plus 1, and that way I can copy and paste. So this is F6 plus 1, which is 32. Okay, and the binomial we use the binomial distribution function again. And I choose this cell, 30 out of 32 purchasers turn up, each with the probability 0.75. And here we use cumulative probability, that's true. But let me copy and paste this. Oops. Okay, the second argument is referring to F2 rather than F1, so the Excel automatically shifted this cell, which I don't want. So let me, before copying and pasting, let me fix the row. So in front of 1, I put the dollar sign. If you don't know what I'm talking about, watch the tutorial video about the absolute versus relative referencing in Excel. I'm using absolute referencing here to fix this row 1 so that the Excel will not automatically shift down the referenced cell when I copy and paste this formula to the lower cells. Okay, and then I can now copy and paste this formula to the lower cells. But of course I should switch from true to false, so that this probability is the probability that exactly 31 people out of 32 people turning up. And the cell below is the probability that exactly 32 people out of 32 purchasers will turn up. Okay? And the corresponding cost is 2 times the number of overflows. That is 2 times 2,000 pounds times the number of people turning up minus the number of seats in the plane, which is 30. So the compensation cost is 0, 2, or 4, depending on how many people actually turn up. And then expected cost is, again, the expectation of a random variable is the probability times value plus the probability times the corresponding value plus the probability times the corresponding value. You take the product of the probability and the corresponding value and sum them up. Okay, for that we can use sum product function, which computes inner product of 2 vectors. The first vector is the probability vector, and the second vector is the corresponding cost. The expected cost when the company sells 32 tickets is 0.0025 thousand pounds. And consequently, the expected net revenue is the sales 32 minus the expected cost equal 31,997 pounds. Okay? So selling 32 tickets is better than selling 31 tickets. It's more profitable. And we keep doing this, but of course we want to save your time by efficiently copying and pasting these things. So let me copy and paste these last 3 columns here. And let me modify. Now we want to sell 33 tickets, and consequently we have one more possible state, that is 33 people turning up. So we add one more row, and let me make sure that this cell computes the probability correctly. That is 33 people out of 33 people turning up. Okay, that's exact probability. let me check the expected cost. Okay, the sum product is computing the sum product of these three numbers and these three numbers. We want to expand the referenced cells. So let me drag down the referenced region so that when we copy and paste these columns to the right, we don't have to do this again and again and again. If these are empty, it's just 0 times 0, so it doesn't affect the sum product, so we should be fine. Okay, so if the company sells 33 tickets, the expected cost is 0.012 thousand pounds, and the expected net revenue is even higher, 32.987 thousand pounds. Now we can copy these three columns again and again. Okay, and what if the company sells 34 tickets and we increase one more column, 35 tickets are sold, we add two more columns, two more rows. It seems that the profit net expected revenue is still increasing, but it should start to decrease at some point because the plane has only 30 seats. Okay, so you don't want to sell 200 tickets when there are only 30 seats. The expected compensation cost must be really large. So it should start to drop at some point, and the question is, where is the peak? Okay, so let's see what happens if the company sells 44 tickets. So if the company sells 41 tickets, the expected net revenue is 37.958 thousand pounds, which is higher profit than when the company sells only 40 tickets. But when the company sells 42 tickets, now the expected revenue starts to drop. It's lower than when 41 tickets are sold. And then it just continues to decline. So the peak is at 41. When the company sells 41 tickets, the company achieves the highest net expected revenue, which is 37.958 thousand pounds. Let me make some nice graph for that. So I'll copy these first three rows and paste around here maybe. And I use paste special. I only paste values, no formulas, just these numbers, and I transpose when I paste. There are some unnecessary blanks, so I use filtering. So I click on the filter icon, and maybe I can just choose from the first column. At the first column, I can deselect blanks so that now only shows 31, 32, 33, 34. So these, blank rows are now hidden. So I copy and paste these filtered results here. And let me just clear this part. Let me plot the expected revenue as a function of the number of tickets sold. So I choose these three regions and then I insert some diagram. So I go to chart, maybe lines, select data, Series 2, I don't need it. Sorry, I remove it. X-axis is series 1. So I choose first column. And the y-axis, I choose this third column, which is the net expected revenue. That's okay. And then let me change the scale of the range of the y-axis. So I right click on the y label and I format axis. Maybe I can change the minimum from 0 to 30,000 pounds. So now you can see that actually I want so actually you can see that the peak is at 41 tickets. Okay, easy, right? I think it was like 1 hour, 2 hour work for you.